friends, today we are going to solve this problem which is called present cells after n days. This problem is a part of the July challenge on the LeetCode. Um, so let's solve it together. So here, as you can see, we are given 8 present cells in a row, and each cell is either occupied or vacant, and it is shown by using either 0 or 1. So if the cells of I, which is the ith cell, is 1, it means it is occupied, and if it is 0, then it means it's vacant. So we need to find the state of all the cells after a given n number of days. So let's try to understand this by going through this example. So here we are given an array of zeros and ones, which shows the state of cells, and we want to find out what will be the state of these cells after n number of days. Here it's a 7 number of days. uh, uh, Here the main focus is mainly these two criterias which we are given here, like if a cell has two adjacent neighbors that are both occupied or both vacant, then the cell becomes occupied. So we need to check for each cell, we need to check its adjacent neighbors on both sides. Since the first and the last cell doesn't have two adjacent neighbors, we can simply ignore one of them. So like for this, the first cell, we can ignore the left, and for the last cell, we can ignore the right neighbor. But for all the other cells in the given array, we just need to check their adjacent neighbors and see if what will be the next state of that particular cell on the next day, and then we iterate the same logic for n number of days, and then simply we will return that cells array in the end as an output. So the brute force approach would be like, we can, for each starting with the first index in the given array, we start, if this is the ith cell, we check with I minus 1 and I plus 1 neighbors, and then we check its state, whether they are occupied or the vacant. And depending on that, we update the value of the cells of I, right? And then we in this way we will iterate through the given array of cells n number of times, if the size of the given cells array is n. So basically it would be a linear time complexity. And let's just implement that one first. So what we can do here is, like this way, we can we can have one helper method which called, let's say, next day present state, and in that we are given an integer array of cells. And what it does is basically um, check um, check the adjacent neighbors of cells. So the next of I shows the state of ith cell, which will be determined by its two adjacent cells. So if the cells of I minus 1 and cells of I plus 1, they both are same, then we need to update the current state of the cell as occupied, and if they are both different, then we will um, as a uh, um, as a vacant. So that's how we will do it for the given length of cells minus 1. And we will repeat the same process n number of times, because we want to find the state after n number of days, right? Okay, so this way, basically the time complexity would be uh, the linear, because big of n, where n is equals to the length of um, um, like n is actually the n is the given number of days, right? And similarly, the space complexity would be big O of n as well, because we are calling this helper function n number of times. So we need to store it in an auxiliary state of the size n. So where n is the given number of days, right? Okay, so um, let's try that and make sure that our code works. Um, and yes, it does. So as we can see, it ran successfully. It passes the example test case. Now let's try to optimize it. So if we understand it more further, as we can see in the example 2, the n can be very large. Like from the given criteria, the n can be up to 10 raised to 9, which is a very big number. And having a linear time complexity may not work in certain circumstances. So let's try to optimize it. How we can optimize and then do better than the linear time, right? So now give, given the given from this example, we can see that the same there is a pattern in the given array of cells state. So um, the the state of all the cells repeats actually after every 14 days. So the same array after I mean the same array of the state of cells um, of day 0 and day 14, or day 1 and day 15, or like if we do compare day 2, then it would be day 16, and so on. So we don't have to repeat we don't have to repeat for n number of times. What we can do is basically we can reduce that number to like n modulo 14, because the 14 is the number where it the pattern repeats after. So the only thing we need to do is update this number n. So instead of looping through n number of times, let's say we can say like count is equals to, we can say n modulo 14. So n minus 1 modulo 14. um, so n minus 1 modulo 14 plus 1. And yeah, so this way basically we since it's an array and with the 0 based index, we can say n minus 1 modulo 14 plus 1 number of times we just need to loop through, and then after that the pattern repeats, right? So we instead of looping through n number of times, we just simply say now loop through only count number of times. And since the n number is an integer which is a constant, so this count becomes a constant, so we are looping through a constant time instead of n, the given n. So our time complexity also increases to a constant time, and as well as the space complexity. So now we don't need a number of the number of days, and same here. So okay, now let's try this and see if it worked. So there it is. So as we can see here, it the example test case is still passing, and we have reduced the time complexity of this problem from a linear time to a constant time, which is a really good improvement in terms of the algorithms, in terms of this particular algorithm. And also we have saved the auxiliary space by doing it to the constant time. So yeah, I mean, I think this is by far the simplest and the easiest problem, the solution, problem solution that I could come up with. um, I tried to follow some of the discussion answers, I mean the discuss solutions, but like pretty much I couldn't follow through, and then some of them are like pretty uh, like pretty hard to understand and come up during the interview time. So hopefully I made this solution more intuitive and easy to understand. I hope you guys like this video, and please subscribe to my channel, and also thumbs up, like, and share this video. um, just I already submitted this solution, but just to confirm that it gets accepted, let me submit as well. So there it is. Okay, so as you can see, it's accepted and it beats 98.67% of Java submissions. So yeah, uh, thank you for watching, guys, and see you in the next video.